Right, we'll start studying BiCMOS circuits in this 19th lecture from chapter number 8. It's a combination of bipolar junction transistors and CMOS transistor. The block diagram is there. CMOS circuitry is implemented in the box, and we have these two Q1 and Q2 NPN transistors connected out the output. In the middle we have the output, which is used to drive this load capacitance CL. First we'll see what is the need. Why do we need this BiCMOS? You know that for increasing values of CL, delays increase in case of CMOS, but in case of BiCMOS the delays increase but with a lesser speed compared to CMOS. This means that for larger values of CL, BiCMOS is a preferred circuit. However, for the values of CL, very small values of CL, BiCMOS isn't preferred because the delay offered by CMOS is smaller compared to the delay offered by BiCMOS. However, there is a disadvantage of using BiCMOS because that is of the loss of extra space, because we need extra space to implement extra transistors. Before we study the first gate implemented using BiCMOS, we study a bit recap from the EDC course, Electronic Devices and Circuits. An NPN BJT in amplification mode is used when we have this base emitter junction forward biased and base collector junction reverse. Right. The silicon, this VBE and IB curve gives us a value 0.7 volt for which the IB saturates. At which the VBE saturates, and this Q1 is an NPN transistor and it's made of silicon. The VDD available at its input becomes VDD minus 0.7 at the output because we have a 0.7 volt voltage drop across this base emitter junction. So disadvantage that the output voltage V output high is slightly lesser than VDD. In chapter number 7 we studied that actual voltage in volts when the output is logic high is VOH. So we get a disadvantage that VOH is slightly lesser than VDD, but in case of CMOS we know it's exactly VDD. In case of VOL, it's the actual voltage in volts when the output is logic 0, and it is 0.7 volt in case of this BiCMOS, which should be exactly equal to 0 volts, which we have in CMOS circuits. This Q2 turns on, and this voltage, the voltage at its emitter is 0, so the voltage of base is 0.7, which somehow reaches to the output from the circuitry that is implemented in that big box. So there is a disadvantage. So we have a number of advantages and a number of disadvantages of using BiCMOS circuits. In our next lecture we'll study our first BiCMOS circuit, and that is a BiCMOS NOT.